today. This is the perfect section to have right before the final. As you saw, the homework page. You're going to be graphing pretty much every type of graph you've done all year. Step functions, absolute values, square roots. Let's just review. Linear or direct variation, we can call this. But the important thing for this semester is to see how closely related all these graphs are. Not see them as completely different, but they have very similar characteristics if they're written in a certain format. Okay, this vertex form. So we have that linear graph. Similar, instead of parentheses, we have absolute value, but the graph pretty much behaves the same. And if I have a value inside the absolute value and change that, that moves it left and right. Opposite sign. So if it was negative over here, my x minus, let's say 2, and x minus 2, it moves it 2 to the right, to the positive side. So there's always the opposite sign inside whatever type of operator we have available. We also had these greatest integer functions, also called step functions, and it did the exact same thing, only instead of absolute value, there were brackets, right? So that also moved it to the left and right, opposite signs. So just that the graph looks slightly different, but all the values basically do the same thing. So that's kind of like a slope of 2. Just like over on a regular one, this is like a slope of 2. So the graph goes up to right 1, up to right 1. On the greatest integer, what does it do? Up to right 1, up to right 1. It does the same thing. So if you see these as being similar as opposed to, okay, now what are all the steps for this type of function? How do I graph this one? It's basically the same. They're all sample. Then we got into what, quadratics, which is somewhat similar to absolute value, just different curve. But same idea. A number in front makes it wider and skinnier. Okay. The number on the inside of the value being squared, that value, that h, what does it do? It does the same thing it did on every other graph. It moved it to the left and right, opposite sign. Okay. X minus 2 squared moves the whole graph to the right too. Okay. Same thing it did on greatest integer, moved it to the right too, and everything. A lot of similarities if we're trying to come up with patterns between all the graphs. A lot of similarities. Of course, the number on the outside moves it virtually. Okay. The inverse of quadratics, if we took this and we switched the x and y and solved for y, the inverse of this would be square root. It would be a half a parabola on the side. And again, instead of brackets or absolute value or a parentheses squared, it's now square root, but it still behaves the same. Minus 2 inside the square root moves the graph to the right. Okay. The value makes it skinnier, narrower. A lot of similarities, and if we look at all our graphs this way, it actually helps a lot. What works for one works for the other. Inverses, this is what we started getting into. Same thing. This value, minus 2, moves the asymptote moves it to 2. Right here. That's where it'd be dividing by 0. And once again, the value here kind of makes a bow. Okay. Lots of similarities. So that's why we're going to be doing these all at once. You're using a lot of the same thought processes and what you do first, what you do second. It's really similar between all the graphs we've done all semester long. All right, so let's just review them all and how to graph a few of them. Because many of these we can graph no problem, but some of them we haven't done in a while. Okay, so let's review right here. What is this called?
Step function.
Also known as the greatest integer function. Either one is acceptable. Notice how it uses a special notation, right? It's a double bracket. graph one of those in a moment. Remember how to do it. Of course, a table always works for all of these, but it's always along this way. This is called, what kind of function in the middle? Absolute value. Very good. Has that V shape. Over here we have a quadratic. It's a parabola shape. These are the main functions we looked at earlier in the year. We started with these two right here, and then we went quadratic for a while. Step functions are greatest integer function. What does that mean? Okay. So we're doing like a T-chart, let's say, like X and Y. Can do, for every graph we can do this. Generally we don't. We want to use this, the idea of things shifting, right, and moving left and right and up and down. That's kind of the way the graph. I'll show you another way as well. But if we had to, we couldn't remember anything about step functions, we do have to know one thing. And that's how it works when you're evaluating. Okay. So recall that we have 1.0, and I want to know what the step value is of 1.0. That's just going to be 1. If I want to know the step value of 1.2, what do you get? Just 1. 1.65. What's the step value of 1.65? It's 1. So really, what does it do? What does the step function do to any value? It just gets rid of the decimal part. So if you put in a 1 point something, the answer is going to be 1. If you put in a 2 point something, the answer is going to be 2. And that's where the step comes from. So you go 1.99, okay? The step value of 1.99 is 1. So from 1 all the way to 1.99, from here all the way to here, the answer is just 1. And that's why it appears flat, because it's not going up, not going down. All these y values are just constant. So it's just a straight horizontal line. But once you get to 2, okay, once you get to 2, step value of 2 is 2. So just 2.0, knock off the decimal, you get 2. And that's why it jumps up to 2 all of a sudden. From 1 to 2, it just jumps up. So that was the step function. That's how you evaluate it. Of course, we'll show you another way that's a little bit easier, but that's the parabolic version. Absolute value, very similar. You guys remember this. It's a little bit easier to calculate, not much going on there. Go through it anyway. So if we're going to plug in -4, the absolute value of -4 is 4. -4, 1, 2, 3, 4, and it goes up +4. All negatives become positive. That's the operation of absolute value. Absolute value of 0 is just 0. Here is just the vertex. Here the, and I can pick any value. Oops. Yeah, I can pick any values. Quadratics is a little bit different. Okay. You generally want to have a center point or the middle of the graph called the vertex. And that we had several ways of doing this. This was the first one. -b over 2a. X, Y. And then whatever value I got here, I'd start my center of the table right there. So, and then pick some numbers to the left. So I'd get this value would be like 2 1/4 maybe. And I'd plug in 2, I'd plug in 1, I'd plug in 0, I'd go that side. And then I'd plug in 3, 4, and 5 maybe on the other side. But I always wanted to know where the middle of the graph was, and then pick points on above and below. Of course, there's another way of doing this. That was vertex form, which is basically completing a square. Complete the square, you'll get a vertex form as well. Sure. So let's practice doing actually these two, the ones I really want to practice since it's been so long. There'll be a rational one as well. Quadratics I'm not too worried about. Done a lot of practice with those lately. Let's see. So, step function. Now, as I mentioned, you can use a table, right? Do all this stuff. That's fine. But going back to here, use your knowledge of, well, what's the behavior of the step function? What is it similar to? It looks very similar to like a straight line. Y equals 2x. Y equals 2x. And I'm going to go minus 1. So it starts at -1, goes up 2 over 1, up 2 over 1, up 2 over 1. So that's y equals 2x minus 1. So what about, actually it's only x minus 1, sorry. So that's just 1. 1, there we go. Nope. 1, nope. 1, there. So it starts at 1, it goes up 1 over 1, up 1 over 1, up 1 over 1. So what about a step function? So why don't we just graph this without the steps? Graph the points. This is probably the fastest way of looking at this. So start at -1 and do your slope, just like you would with a linear or direct variation graph. And instead, same thing you learned, 8th grade, 7th grade, whatever it was, yesterday. Okay. Same thing. Normally you just connect these if it was, just a regular linear function. But if it's a step function, instead, draw steps. So knowing what the behavior does and how it's similar to just regular old lines will save you a lot of time. And of course, make those open circles at the ends. And I can't see too great from here, but you get the idea. Okay. And our solid dots at the front. That's probably the fastest way. No table necessary. We know how to do the linear direct variation way. We can easily just make it steps. Instead of connecting all the dots, we can make steps. That's probably the fastest way of doing it. So I'm doing more math. Most of the math I'm doing here is based on patterns, not really on calculations. It works just as well, and it's even faster. Absolute value, same thing. Okay, you could go through here and say, the middle of the graph, what will give me a 0? What number I plug in here will give me a 0? And say -2. Pick some points to the left, pick some points on the right. But you can also just say, well, I know what absolute value of x looks like. It starts right here. Well, with a +2 inside, that just moves everything to the left of 2. And someone else might recognize that, well, isn't it just y equals 1 over 1 x plus 2? And you start at +2, up 1 over 1, up 1 over 1. Like, yeah. From this part of the graph, it's just same as, graphing y equals mx plus b. It's just when you get to the other side, instead of continuing down here, instead all these negatives become what? Positive. So it looks like that instead. You'll get the same graph if we go through and we pick points and do all this, but we want to try to get away from that. Think of it as translating and moving back and forth, up and down, as opposed to relating it back to y equals mx plus b rather than, okay, let's crank this out one number by one number. Unless you have that table function on your calculator, this is not really practical. It takes up too much time. So those are all I'll call them the linear-based graphs. So they operate just like here: right, run, y-intercept, absolute value, greatest integer. All three of these pretty much operate the same way. If you know how to do y equals mx plus b, you know how to do absolute value and greatest integer. Then we'll get to quadratics, right? And square roots, which are inverses of each other. We take the quadratic, switch x and y, solve for y, we get the square root. So those are basically the same. And then lastly, I wanted to go over some different vocab here. We have what we call just regular linear. We can also call that, based upon last night's homework, direct variation. Same direct variation. There's some special names depending on the values in the direct variation. If the slope is 1 in direct variation, you get something called something like this. You get y equals x, or y equals 1x. Special name for that is the identity function. So it's a special case of linear or direct. And if we get a case where there is no slope at all, so it's horizontal, 0 slope, that's called the constant function. So you'll see that in your homework. You'll need to identify these. So this is when the slope equals 1. This is when the slope equals 0. And here is when the slope equals anything else. So the left and right hand sides are just special cases of direct variation. Lastly, went through all of these. Constant, we just talked about, direct variation, how these are related. Square root and quadratic, those are inverses of each other. Absolute value goes back to linear. Greatest integer goes back to linear. These two, rational and inverse, very similar. Inverse is when you have the variable on the bottom, like y equals k over x. Rational is when you have like variables on the top and bottom. Okay? But these are very closely related in how they look. Okay. So there is a difference. So make sure you know that inverse just has a variable on the bottom. Rational will have x plus, x minus, top and bottom. So here, again, operates the same way. We know what this value does in the bottom. Here, it's very similar. So before, we had something in the square root. It moves it left and right. We have something in here. Inside those steps, moves it left and right. But with the inverses, it's on the bottom. But it still does the same thing. It moves it left and right. Nothing more than that. So if we know that ahead of time, we'll know that. What value makes this 0 on the bottom? You'll start at -1, and you'll know that vertical asymptote is at -1. Pick some numbers to the left, like -3, -5. Numbers to the right, like 0 and 2. Get the fractions, plot the decimals. You'll notice that this is a negative right here. So what happens when it's negative in front? A is negative. A, the value on top, if that's -1. You know it. Notice how it goes to the other side. Kind of like the opening up, opening down. Similar to a parabola. So after you plugged in some points, got your decimals, you would see it just looks something like this. Of course, your lines would be much better than mine. Symmetric? What's symmetric? But of course, I'm not going through all these calculations because your final is multiple choice. You don't need to know exactly where this point is and that point is and make sure it's precise. You just need to know, like, okay, that's negative. Okay, so it's going to open on the other side. That piece of information is what's going to enable you to answer this question in, like, 10 seconds, as opposed to, okay, I got to get make a table, and that's going to take 5 minutes. Just knowing like, oh, that one negative, hey, that negative does the same thing it does on every other graph. It makes it open the other way. So negative on a parabola, oh, it's going to make it open down. Negative on absolute value, oh, it's going to open down. Okay? So knowing that, how it operates for all the graphs will make things easier. Just have to pick the right graph that's right in front of you. All right, and that's about it. Oh, we're going to have some matching. So just by looking at the equation, do you know what type of graph it is? So like, what type of shape is this? A? What shape is it? Parabola. So that's a quadratic equation. This is a simple square root. This is a rational. This is a set. So in general, you want to be able to just look at these and do what I just did. I know that's that shape. This is the square root. That's rational. Kind of looks like this. There's these sketches of what they basically are. And then it makes it quite easy to match up. Okay, so 5, that looks like a square root. All right, this looks like a rational. No problem. Don't have to make t-charts or be precise, but just know the general shape of everything. So again, very perfect section for review that covers the whole semester as far as graphs go. I'll let you work on that. We went over the answers, I believe, right? A few of the evens you had to check, maybe a few of these evens. All the rest of them are on the back of the book. And I'll be checking all the 8-3, 4, 5 tomorrow. Check them all together. And if you want to do these graphs precisely, you can print out the graphs I posted on Schoolroom. And collect them all tomorrow. Do make sure you finished all of 8.3. Some of you only did the worksheet and handled it out. Remember, there's 4 more graphs plus 2 review questions after that. Okay. So make sure you finish all the way up to like 59 and 8-3. And